Hello again. Welcome to Methods exam, 8 high exam preparation. Today we're going to solve VCE exam methods exam paper 1, 2023, question 3. So this question involved with A, B, C, D, E. So 5 small questions. So let's solve it one at a time. So before I do that, please remember to subscribe the channel by just clicking the bell. Just give your thoughts to support this channel to continue to grow. So we will build a community. So at the moment we try to reach to more than 100 episodes. So nearly done the first 100. So just give your thoughts. When you subscribe, you will get the latest notification. Thanks for that. Okay, let's do the first question. We have a function, gx is 2 to the power of x plus 5. So we want to find the first question. We say, what is the limit when the x approach to negative infinity? So what is the limit of gx? So obviously this is an exponential function 2 to the power of x plus 5. So when x approach to negative infinity, so that 2 to the power of x will approach to 0. So 0 plus 5 will be 5. So first question is pretty simple. Now second question, we needed to find a derivative of gx. So therefore, we need to decide what is the derivative of 2 to the power. This is a derivative exponential function, but not an e-based, not it's a 2-based, or it can be 3-based, could be any base, could be a-based. So how do we do that? So let me just explain to you. I'm going to say using the y equal to 2 to the power of x, let's say letter y to 2 to the power of x. So both sides choose e-based log, natural log a, y equal to, so x bring to the front times by log 2. So I'm going to do, this is we treat it as a differential equation. So we did left-hand side with dy dx. So we got a 1 over y, then times by y, derivative of y, because that's the composite function. Then the left-hand side is the dy dx has become log 2. So differentiate y with respect to x. All right, so now we swap y dash equal to log 2 times by y. So what is y? Y is 2 to the power of x. So we substitute back. So therefore, the derivative of g 2 to the power of x is log 2 times by 2 to the power of x. So obviously, if you have a log 3 to the power of x, derivative of that will be log 3 times by 3 to the power of x. So a based will be log a has to be positive, so a to the power of x. All right, so that's the formula we can use. But how do you get it? So we just show you how to work it out. Okay, so derivative, so that's for, therefore derivative gx, I'll use the formula we just did. So we derivative of 5 is 0, so we got that. So therefore, if I say derivative gx is k times by 2 to the power of 2x, so k must be log 2. So question B done. Question C. So if I have a real number called A, find in terms of A equation of tangent. So we need it in terms of A. We don't know what A is. To G at point A and GA. So this the. So let's find out the equation. So equation we know the tangent is a. Let me just set up as mx plus c. So what's m? M is the derivative. So m is a derivative of g. So we know m is a derivative of g when x equal to a. So let's do that. So we derivative gx is that. So substitute, plug a in. So we will get the m. So that's my m. M is log 2 times by 2 to the power x and plus c. So now we're going to decide what a c is. So GA is substitute 2a plus 5. So therefore, we can find out c is this expression. So in terms of a. So therefore, the tangent will be y equal to mx plus c. So that's it. That's pretty long, isn't it? Because in terms of a. So we've done a tangent. Now we're going to find what about a tangent at the 0, 0, which is past the origin. Origin means 0, 0. So at 0, 0, we can replace the x with 0, y with 0. So therefore, this is my just c. So that's a c, which is we can find a by using GDC to find that equation. So CA is approximately equal to 2.617. So therefore, my y is mx. So that's my m. X plus c. C is 0 because that's a 0. Because of passing the origin means you don't have the y-intercept, or the y-intercept is 0. So therefore, if I'm using the graphics calculator, so that's approximately equal to 4.255. So that's my m. All right, so that's the question C1, C2. Then question D, if I have a new function called hx, which is 2 to the power of x minus x squared. So we want to find the inflection point. So inflection means point of inflection, we know the POI is when the second derivative must be equal to 0. So we need to find out what x is. All right, let's solve that. So derivative, first derivative, and then second derivative, so equal to 0. So the 2 to the power of x equal to that. So x equal to this divided by this using graphics calculator. So you can find a 2.06 for the x. So we substitute into the original hx. So we find that the y is negative 0.07. So that's POI. Done. Question D. Then we need to find that the trend when the interval, what is x? So x belong to what? Interval means what is x? So that hx is strictly decreasing. So we know when the function decreasing, the second derivative or first derivative must be negative. So the first derivative is this, negative. I'm going to use GDC to draw the graph. So when you see the graph below, negative means here, the yellow part. So that's the negative side. So between 0 point, we can trace those 2 points. So the x must be using GDC to trace is between 0.49 and positive 321. So that's the interval for x when the function hx is decreasing. All right, that's all we got today. So thank you for watching. I'll see you next time. Bye-bye.